Okay, so let's look at how we get the mesh to start doing this 3D model. So the first thing is you want to find them, if you're using a mesh to remix, you want to find that mesh somewhere online. In this particular case, we're starting with the 3D printable COVID-19 mask V2 from the Factoria guys. And you can see the Thingiverse number up here if you're looking for that. And I'm sure the links will be available as well. Once you've got to this, now you can sign in. I'm not signed in, but you don't absolutely have to be. It's a good idea to like and comment and provide feedback to the supplier. You can download all files from here, or if you're only after one of the STLs, and we are after a few in reality because you want these two green parts as well. They're going to be printed as is. There's no need to modify those. We're just going to modify the mask itself. So thing files, and you can pick and choose the individual files to download. We're looking for mask body wide, or L wide for large, wide, and hit download. That'll download that to your downloads folder or wherever you've got it going. Now I'm going to then go over to my recap photo application, and I'm going to open that there. So we'll load the model, pick mask body large wide. Now I've got two because I've done this before. Hitting open, I'm going to overwrite my existing project. And you'll see in here, now we have the mask that was shared on Thingiverse. Now we want to remix this to clean it up a little bit. There's two things I want to do here. I want to be able to deal with the main mask body, and I also want to have this flat section. Now it's flat on the bottom for printing, flat to the print bed, and flat on the top probably because it's mostly convenient, but it also doesn't need to be anything other than flat. I want to slice that there so that is separate, and I make sure I don't muck up this interface between the printed bits that hold the filter that fit in here and any changes that I make. So the first thing I do is split that off. Now I do have that already done. That's over here, and you can see that is going to be imported into Fusion just like that, and that can be manipulated in there. But going back to what I was doing, we want to split that off. So the first thing I want to do is I'm going to slice and fill, use that tool. That creates a plane to cut. Now I can, that is centered on the center of the model, and that's fine, but I want to transform that. First thing you note is you can flip that over, so it'll do the top or the bottom as a trim. But let's transform that first. Clicking that allows us to do a few things. You'll see these gyro that comes on, which gives you the 3 rings that you can rotate. So you can rotate through the horizontal, the vertical, and the vertical other axis. So if I grab that little thing there, you can see that rotates, and you can't actually see the angle, so I'll use this one here. You can see the angles being specified, and that is rotating the slice. Now I don't want to have a funny angle, so I'm going to turn it off and go start again. The other thing we can do is vertically move that through perpendicular to the plane itself. So just left clicking and dragging, we can move that up and down as far as we want to very easily. There's no dimensional measurement there, it is just a feel thing. So what I'm going to do is zoom in. I'm going to then scroll or move this down until I just see that first layer disappear. So there we go. My slice plane is going to slice off this top section and retain it. Alternatively, I can flip it and it will retain just the bottom. Yeah, so flipping it back, that's what I want because I've already got the bottom elsewhere. I'm going to hit apply, and I meant to mention there is fill and no fill. That is relating to the surface at the bottom. So if I just cancel that, you can see on the bottom now that has been filled. I'll change that to mesh. You can see this has been filled and is not left open. That is because it was filling. If I left it to no fill, that would be open, and you can see the back side of the mesh on the inside. So we have that split off. And the last thing I want to do, I don't want to, this is a mirrored object on both sides, or it will be when I'm finished. So I don't want to have to deal with two sides separately, so I'm going to slice that again. And I'm going to slice it in the vertical, or in the, bring that around, make it 90 degrees, where I can see that dimension. Come on, 90 degrees, there we go. Because that then can be mirrored and duplicate the other side. So again, same thing, fill or no fill. I want it to fill, so hit apply, and then we're left with this half the body with the face sliced off. Now to export that, really easy. You can do some analysis here, so detect issues with the model if you want to, whether intersections, holes or particles. I'm not worried about it. I know it's going to be fine when I get there. Going to export this. Now, you can go to the advanced section and you can define exactly how you want it to export and play around that if you like. I'm not too concerned. I like to use quick export, and again, you can pick all the different applications and it has predefined settings for those. So I've picked Fusion 360 quads, so it'll be an OBJ model, and you can either pick low, medium or high resolution. I think I'm going to pick medium for this one and hit export. You tell it where you want to save it. Now I've done that already. I've got mask, body wide and face only that I've already exported, and sidewall and face only that I've already exported for use in Fusion 360. So once you do that, that can take some time to process, so don't be in a hurry when you get to this point. Let it run, just be patient with it. There's a lot of processing going on, and when it's done, it'll come back to here, and you can save that and go back to your dashboard, and it'll be there when you're ready. So next step is we'll go into Fusion 360 and see how to bring that into Fusion. Okay, so back in Fusion 360, we want to look at how we get that mesh into Fusion. Really very simple. I've got a blank one here, so we'll start from scratch. There's a couple of ways you can do this, but the easiest thing, start a new drawing, save it as a name that you want to, I'm sure what you want to call it, and then I just would insert, actually I would open the browser and I would create a new component, because I like to work in components, but not necessarily entirely at all, and I'm going to say mesh body. And you can structure this whatever suits you, and I'm going to insert a mesh into here. Now I know I've got these exported already, so I just need to go to my OBJs. So when you get to get there, so the first thing you want to do is just go into the insert mesh, browse to where you exported the models from recap. So I've got them in here. So we're looking at face only, and we want the side walls where you actually want. So I'm going to grab that and bring it in, and of course you can position this by transform and all the usual tools. If I turn the origin on, it's looking relatively good, so I'm going to leave that exactly where I expect it to be. You've got the options for the unit type, because the STL doesn't have any unit type necessarily. Flip, direction, centroid, all those sort of things. Now, I actually had some issues when I brought this in originally. I needed to scale it. So if I measure from here to here, that's 85 millimeters, so that's coming into the right scale for me, because I knew that was around that. Again, the accuracy is not terribly important. Close that. So that's my mesh. I'm going to create a new component, and I'm going to say mesh flat face. And same thing, I'm going to insert a mesh, and I'm looking at face only, bring that in. Now, see, this is orientated around 90 degrees. I don't want that, so I'm going to simply rotate that around 90 degrees. And again, you can put it in manually if you wanted to. You've got the move to ground function there clearly, and let's just try that, see what it does for us. Move to ground, go back to the right, that's okay. And you can see there, if I transform that down, I don't actually want to move that because that is joining nicely for me there, which is expected because the two meshes are where they're supposed to be. But I notice they're not lining up in that plane, and the origin is away from the center, so I'm going to scoot that across a little bit, and you can do all sorts of things you wanted here to manage that. Go back to the right view, and we can see a bit of an offset still. Now this jumping, when you move this, will vary dependent on how close or how far in or out you are. That's looking pretty good, so I think that is about right. So I'm going to hit OK there. Now if I go back to the top here, now you notice they're activated. We can see the two things, and we can then start looking at how we're going to manage these. Now if I go back to my original model, and if I scroll all the way back down to this end, so I'm going to move the timeline back down to here, roll history marker here, we can see I've got a bunch of mesh bodies because I was playing around with it a little bit. One of the things I actually did do was split the mesh body down the middle. So I turn those on. Because I'm going to mirror it, I decided to do the same with the bottom, and I ended up with a couple of other splits. So one of the things I've done, I simply in this particular version I just put in the meshes all under one body, so I knew what was the original. So I've got the side body there, and I've split the mask there as well, and that is simple enough to do. If I turn the mesh body off, we can go into here and activate that, and we can run around with a number of tools, and we can split that, or you could do that in Fusion 3, so in Recap as well. Okay, so you need to split that down. Like I said, I've done that because I want to be able to mirror that. The next thing I did, I played around with a few things with this model. You can see there I've mucked that up and cleaned the inside out. What I have done in actual fact is, if we have a look at some of these sketches here, I'll move that forward a little bit. Build out a few construction planes, and you can see here these are being put into here because I did not have this body wide activated when I was creating these construction planes. Now that's these little planes in here. What I have done is built out some sketches. Now you can see there, if I go to top view, it's a bit more clear. I have projected, or rather bottom view, that plane there, and then I did a plane that sat through the edge. Let's turn on the next mesh through the middle of that bulge there, because I want to change this into a solid and just be something a bit more useful to me. And then I did, the last thing I did was the top of that that shape there as well, because that's the last one I'm concerned with, because that is the interface where it's going to snap into. So having brought those in, you're ready to go and start manipulating them. What I did do there, I split the mesh again in here, because what I wanted to do is have a few bits and pieces to play with. End of the day, what I did is I took those sketches, and if I turn them on, you'll see them. Sketch 1, 2, and 3, and you can see they are sectioned through the actual the body. So I created a plane there, an object, extruded an object there, which was in the side view. You can see in the original design there is a little step in that. Then I extruded the next bit, which was the connector piece, and the last bit at the top. Now I know this is all messy on the side, so it's a bit of cleanup. I was really trying to figure out what's going on, and I moved on to other areas. But what I ended up doing was, what I found was, if I scroll back to here, that because of the way I brought things in, it wasn't actually sitting on the origin plane. So when I put the origin plane, I mean, if I turn the origin on, this plane here, when I split the object, so I want to clean up this edge to make sure when I mirror it, it's going to be a clean edge. So I manually extruded these faces. So we can see there's a bit of an odd artifact there. So I extruded those manually to bring them well past the origin, and then I simply did a split body to split off the bits that were projected past the origin, and then removed those. Now I'll turn that body back on again. So now I know I have a body that is clean to that origin plane. Let's turn off those construction planes because they're confusing things. And when I mirror it, it's going to be nice and clean. So if I mirror that now, there's not going to be any. Let's do mirror bodies. That mirror plane is, we've already got selected. Okay, and we can see it's a nice clean join. There's no concerns there about it being broken. Not going to add that in. So the next thing I wanted to do then was chamfer that edge, and I could simply use the chamfer tool in here, where, so if we undo that little thing there, it's very simple chamfer. Now because it's coming from a mesh and I've projected that, we need to select them all, even though target chain is turned on. But I can simply go around, holding control, pick all the different edges, and then I chamfered that, I think it was the 2mm, and that gave me that profile there. Now if I turn the meshes back on, and there you can see, if I native to that face, that now matches that mesh profile very closely, and you can see the step there I was talking about. The next thing I wanted to do was add this chamfer in here and clean that up as well. Now I decided not to go with that. I ended up doing it slightly different, where I've chamfered that straight through in the end. So that got me to that sort of shape. Now again, I wasn't happy with this back here, and it needed to clean that up a little bit, and there's a few things to do. So I went through and did some cleanup. We created some planes and tidied things up to get this edge cleaned and to a point where we can continue forward with it. Now I'm going to skip forward to a point where that's finished, and we can continue with the meshing from there. You can see the next thing I did was create a mesh, so we'll pick it up from this point onwards. Now I did struggle. I had originally wanted to simply chamfer this edge here. So for example, if I grab that and go around, I should turn that mesh off because that's just going to confuse things. Zoom out a little bit, orbit a little bit, keep selecting this outside edge. What I want to do, let's turn that mesh off for the time being, is chamfer that down. Now it's not an even chamfer. You can see if I turn that mesh back on again, the dimension there is longer than that dimension there. Now I have measured that previously, but what I want to do is change this to do 2 distances, and you'll see then we can specify, when I find the arrows, 2 dimensions to move the chamfer by. So I can push that one a little bit, and I can push that one a little bit, and you can see there, looking at this front edge, we have this chamfer building out. Now I can move that incrementally as I want, but what I found was I couldn't quite get it to where I want it. And I found, let's just make that 6.5. This is one problem with converting from imperial to metric, I expect. You can tweak that accuracy, and then we'll get the other direction. Try 3.3, and you see it starts to error out on me there. Now I'll show you why. If I take that 3.3 back to 3.2, we'll see what happens. No good. 3.1, no, and it'll work. So that's looking fairly good. If I turn the mesh body off, we can see that it matches on this edge here, and if I tilt it up, you'll see as we come around the back here, there's now, if I get rid of that selection, let's turn those sketches off. Now you can see there's a little landing there that we don't want. It's not perfect because again it's coming from that triangulated mesh. I wasn't happy with that. I wanted that to be more clean. Probably wouldn't matter for printing because it's really very small. If I have a look at that, in some of the worst areas, if I do a distance from there to there, it's 0.05 millimeters, so really insignificant. But I'm a bit of a perfectionist that way. I didn't like it, so I tried a different process. So let's can that fillet there. What I did next was I created a new plane, and that plane was so that I could, a new sketch. Now you see that sketch, I had the body turned on, so sketch 11 there. I've created that sketch, not the plane, turn the plane off, on this face here, and what I have done is I've projected this long face, that face, and that face. I've defined the chamfer that I wanted and extended past that because I'm going to use that as a cut, and I want to follow that all the way around. The next thing I did is I removed these two faces. So I went through here, selected all of these faces, and I'll do that for you right now, and zoom in, face, 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 and that one's already selected, and hit delete, and Fusion 360 rectifies that and closes all that up. Now that gives me a nice consistent edge, and because that sketch is already there, it's not going to be a problem. The timeline helps with that, and then I simply move to the next step of sweeping that. Now I'm going to undo what I just did because that was already done, and we removed that, and then we did a sweep. Now if you haven't done a sweep before, it takes a minute to process, so it's locked me up. It takes this plane and runs it around a predefined line. Let's give that a minute. I'm going to pause while that processes. Alright, so you can see that is now trimmed using the cut function all through there. What I'll do is undo that and I'll show you how that works. So we simply go into modify and, into create sweep, and I select the profile I want to use, which is that one, and I'm going to select the path, which is that, and you see it's defaulting to cut because it's recognized that's probably going to be a cut. You could change that if you want to, of course, as with most things, and you can assign a lot of variables in here. We just want to keep it nice and simple, and I want to extend that right around the objects. Holding control down, I can extend that. I'll zoom out a little bit, and we go all the way around, and we can extend that to the other side, and it will profile cut that all the way through. Now I can cancel that because I don't want it to actually run. Oh, I confused it there. Let's just pause that and we'll wait for that to process. Okay, so that's finished the processing. It struggles sometime when you're recording screens, and we can now see that's nicely chamfered the whole way around, and there's no daggy little edges we need to be concerned about. Okay, so that is good, and I can turn the mesh back on, and you can see that's a nice tight fit and should not affect any of the fitting of the objects. So I'm happy with that plane there, and when I want to I can mirror that nice and easily, and everything is pretty tidy. The next thing we're going to do is create a mesh body. Now I've done that already, but to do that there is really simple. We hit this button here, create form, and we can start creating the body of the mesh as well. Now I've done that under here. Whether you do that as a separate body like I did over in this version here, that's fine. Really easy, and make your choice, doesn't really matter. Alright, so we'll continue that in just a moment. Okay, so to continue with the mesh form, in this particular case we're going to do it on the mesh body, so I'll turn that on there. We want to try and replicate this with a single fusion object. Now, there's any number of ways you can deal with this, and you can certainly use this surface here. You can edit it in the mesh tools. I opted to go down a different route, and what I'm going to do is we've created the mesh form in this demo version, and what I'm going to do is I'm going to start creating some objects there. So I'm going to pick a plane, and let's just pick that plane there, and if I go to the right side we can see what that's going to be like. And we want to pick this option in the center or 2 points. So let's go to 2 points, and we're creating a new body. So let's go from there and let's pick it up to about there, and then we get a single plane in that space. Now I'm going to increase the faces because I know I'm going to need some more because it's a fairly complicated curve, something like that, and hit OK. And that's not very useful to us. We can certainly double click on that and we can hit move, and I can transform that over here and get that kind of where I want it in place. And I can also do things like the angles and sort of align it, but of course the mesh we're moving to is not a flat plane. Thing I'm watching for is just I don't want to occlude there. You see the bottom corner, it's now projecting into the mesh. I'm trying to avoid that, so maybe we just do a bit of an angle on that. That's fine. I'm not too concerned about being pedantic about it because I'm going to use a funky little tool Fusion has here where we can pull an object to a surface. So I'm going to click on pull, and what I'm going to do, so we've got a couple options. We can select automatically or we can select the targets, and it doesn't really make much difference in this particular example because it's only the one object. So what we then start doing is start building out what we want to move. So what's it going to do, when I pick an object, pick a vertex on the mesh, it's going to pull that point over to a logical assumed point on the mesh that I'm looking at. And we can do that right across all of these points, and it will bring them over to the surface of the mesh. And you can continue doing that all the way through. You can get some really funky shapes. I wonder if I can select all these in one go. Doesn't look like it. So I'm just going to go through and keep doing that. And of course you could do this for as little or as many points as you want. And it would be one good argument for having multiple points or less vertices to have to manage at this point. But the more vertices you've got, the tighter fit it will be to the existing surface. Okay, so I'm nearly done, and that is the last one there. So you can see that is now quite a tight fit, but at the top you can see, if I just try to orbit that around the right way, to me to do that, what happened? I cancelled the order by mistake, so let me fix that up again and I'll be back in a second. Actually, just while I'm doing this, I will show you something very quickly. I did notice I made a mistake. You can select them all. You can do them individually, and when I was trying again, I simply held shift down and pulled them all over, and they've all snapped to that surface. So that's nice and quick. Don't forget to hit OK, otherwise you cancel the option. Now once it's in place, it isn't perfect, and there's a few things we need to do. We can do a couple of things to match this surface here. We can do adding, or we can do any number of different things. Key thing here is the modify tool, and we can do either, we can pick a line or a vertex or a panel, and they're all variables. Plenty of training on that. For argument's sake, I can pick this point there, and I might want to simply move that manually up until this looks like it's in about the right spot, or I can grab that, and if I hold, I think it's Alt, it's going to add an extra surface in there. And I can do the same thing over here, Alt, and it will add that in, and I can do it there as well, or alternately I can control that, undo that, I can select that and that, holding Alt, it'll add in another surface. Now obviously that may not be the best thing. Alternatively, you can simply grab that, and not holding Alt, you can drag it up, and then if I want to deselect that one, I can deselect them all, and I can come to there and there, and I can move them up as well, and then I can deselect that and simply select that one and move it up, and then maybe I just want to pick that point and move it up. And you'll see here now that's moved off the surface. Again, I could select there and I could push that back manually, or I could go OK, and I could go back to my press pull in the modify section, the pull function, and just start picking these points. Or again, just do that, and it will match those nicely for you. And what you can do is you can either add more meshes manually like we did to start with, or one of the cool things is, like I said, using the Alt tool. If I go to the top view, rotate it around a little bit, I can hold Alt and I can add vertices in there just as easily, and as I add each one, it highlights that. Now I've selected that whole line, so it's adding them to there. I can do things like change the angle of that. I can physically move that up, and I can continue adding to that mesh using that Alt if I want to. And again, when you get to a point you're happy, you can try that press pull or the pull function, and maybe I just select all of those and they suck that in again to the mesh. Now the other thing is, if you do, I've cancelled that, that's not what I wanted to do. Just do that again, select all of those, they get pulled in, go OK. Now if you do add another mesh, and let's do it in this plane this time, go to the front view and 2 points, so let's go from there to there, there to there, and add a couple of extra rows in. OK, and selecting all of those by double clicking, I'm going to select my modify, and I'm just going to drag that over until it nearly touches. And again, you can play around with it all you like to get it where you want. It doesn't have to be too close. Let's try that press pull again, and because it was already selected, it's done it automatically for me. Go OK, and I'm just going to pick this point here, and if you have problems selecting, sometimes just turning that mesh off. Oops, sorry, mesh body, not bodies, not all of them, just the mesh. There we go, and modify, and just move that across. If you need to join two meshes, now let's get rid of that mesh body. If you need to join these two together, there's a function called weld or join, weld vertices, where we can come along and we can say that vertex needs to line up. Oh, let's start at the bottom. Try that again. Let's say we want this vertex to line up to there, and it will actually physically join those vertices. Be aware it's going to adjust the meshes to suit, and that one to there. So it's going to try and maintain the vertex rules, and we can have that one still being out on its jolly lonesome because maybe we want that. And again, when you're done, turn that mesh back on again, and if you're not quite sure, simply use that pull command. Maybe we can try something different. Select all of that and do pull. Okay, and it's done its thing. And pull that maybe. Alright, so so you can work your way around. Obviously you wouldn't do things like this and build out the mesh. Now if I go back to the original model, we can see I went right through and created this single surface here. Once you're done with that, what I've done is I've turned that mesh off, and I've simply used the thicken command. So in here, thicken, that takes that surface which has no depth to it and gives it a depth. Now that can be whatever you like. Now just be aware, you can see there these construction lines. They're going to be, if you've got some anomalies inside your mesh, it's going to be a bit weird sometimes. You can do it sharp edge, soft edge, or no edge, so it can be just two planes, and direction can be normal to the surface, or you can do it as an axis. Let's pick that axis there, so you can see it's moved it only in one axis. In this case I wanted it normal to the surface. Let's do that, and because I haven't been very good with the mesh here, you can see it's created some really weird anomalies there. The way to look at that is to change the view of the mesh to control frame, and you can see what's happening. Now if we go, if we just undo that thicken, now in the mesh space you don't have timeline here. Can I add it in? No, I cannot capture timeline because it's the simple reality of the mesh environment. So if I turn that control frames on, what you can see is, if I come to this side, it's a bit easier to see. So you have this control line here, goes up and then down and then back up again. That's bad for that purpose, so what I want to do is clean that up. Now there's other ways to do it, but the easiest manual way is to select those, go back to your model. You can use the control lines to modify your mesh, and I can adjust that, and I can maybe move it out, or I can move it in, or wherever it needs to be to make it look like it should. Similarly here you can see that's intersection point is overlapping, and if I clean them up, hopefully, if I do a thicken again, thicken that way, go OK. You can see there we don't have that such a nasty little feature, and if I turn that back to normal display, it looks kind of okay. Now in the case of the mesh, that was where I wanted to get to. I did do some extending on here and things like that in the other environment. That's going to come in not the mesh environment, in the Fusion, not in the form environment. So when you're finished, hit finish form. Now because you've used that form and it's a native Fusion thing, we get this view. It's a nice simple view, really high performance, and we can use standard Fusion functions on a lot of this here, like extend surface. Alright, so really nice, and we'll continue with that in the next bit. Okay, so back in the original Fusion 360 model, I've created my surface here, and I've thickened it as we demonstrated before, and I've got that in my Fusion environment as a native body, which is that one there, which is lovely and good and easy to work with. Now you'll notice this extends past the surfaces that I'm interested in. Let's try and get rid of that origin, and maybe the sketch as well. There we go. It goes past the surface that I want it to mate to. Both in this direction and in the vertical direction, goes past the origin. I did that deliberately because I want to trim it again to ensure I get a clean environment. So really, really simple. The next step, I split the body. In fact, that's the you can see there. I did let's do an edit on that. I have selected the body to split, which is my main part here, and splitting tool, which I selected this bottom, which is going to be the print face, and that has split that. Cancel that. You can see there's a split line here, and I get a new body, and then all I've done is I've simply removed that. So it's by simply going right click, remove, and that disappears. It's still two separate bodies, but that's fine. And then the next thing I did was split the other axis, and you can see there doing exactly the same thing but using the split plane here. So if we edit that, we can have a look at the feature. We selected the body, we selected the splitting tools, which is that face, and that is going to split that along those faces to be nice and clean, which is good. We hit OK there. That gives us actually three bodies in this case. So we get these extra bodies, and all we want to do is remove those as well. So again, come over to here and select both bodies and hit remove, and that removes them from the design, and we end up with this nice clean surface. Now I want this face, this body, and this body to be joined, so I'm going to use the combine command to give me one continuous body. You can see there. Let's turn off actually, I didn't combine it. The next step I did was a cut. So you can see there, I wanted to trim that down, and I did that deliberately to give me a nice clean edge. I could join them, but I decided I didn't want to at this point. I wanted to leave it right to the end, I think, up here a few more steps. So what I actually did was use a cut. So I used the mask body as the tool to cut this body here so that we had one continuous edge that was matching. And I've said keep tools because I want to keep that face. What it's allowed me to do is do a bit of tidy up on the mesh. So I created a fillet around there because that's where it's going to sit on your face, and that was nice and easy. So we just did at the feature, we were able to certainly pick one edge, which is that sharp edge, and create a 3mm fillet, which it allowed me to do, and that is then comfortable on your face. I did the same on the back. Now you could do them in the same command if you wanted to, of course. But the main reason why I haven't connected this yet is because the next thing I want to do is, for the purpose of this, we need to be able to fill it with a liquid or a gel to hold cold volume. Now, if you printed this in 3D right now, the edges would be all the edges would be solid, and the center would be filled with infill. We want to avoid that, so we need to do what we call the command is in here, a shell command. And really simple. What we're going to do is select the shell command. Now I want this face and that face to be hollow, and we give it a dimension. I'm going to say 2mm in this case, and that will create a consistent edge all the way around with a hollow 2mm thick. So we did that there, and you can see I should have actually improved that. I could have gone edit and picked both surfaces, and I think that would have worked. 1.5mm in this case, and that creates me a hollow entity. Can I trim that? Let's not do that. Let's just do a new inspection section through there, and you can see hollow all the way through. So that can then be filled when we're ready, and it's nice and consistent right through the surfaces. So we know we've got a 1.5mm through every single aspect. Alright, so the next step I wanted to do was to join both these bodies so that we don't have two bodies anymore, we've got one. Again, I just use a combine tool, and we just do an edit feature on that. We simply select target body, you pick the body you want it to go to. In this case, I selected the main mask part, and tool bodies are the bits that are going to be attached to it. I've used join here because I want them to be a single body, and I opted to keep the tools in case I need to go back to it for some reason. So that was done, and then I realised once I completed that I needed to move things around, so I did some tidy up, moved the bodies around in my project manager into the right area, and then so now I've got this mask. I need to complete the other half of it. So I've simply done a mirror command, which is really easy. Select the body, and I use the mirror plane, which is that surface there, to mirror it across to the other side. And once on the other side, we end up with two bodies. To combine those, it's really easy. We simply want to select the combine tool, where we select both bodies, and one being the tool, one being the target, and the join option to join the two into a single body, just like that. Now there is a identify. You can see the marks there identifying, but that's okay for what we're trying to do. You can see one nice continuous body, which is very nice. Okay, so the next thing is we've got the whole body, single body here, and it is hollow. So if we show you that with an inspection through here, it's a hollow body, and we can print that nicely in hollow. However, we need to get a way to get the fluid in there. So the next thing we're going to do is create some additional resources. So what I need to do, I want to put a nozzle on this plane here, sticking out of the bottom of the mask. Choosing that one there because this nose will be up here. That'll be hanging off your chin and be away from your face, and also not obscure anything. So what I have done is I have put a point on this, on here, and on this line here, because there's no actual plane to pick here, but I'll show you why in a moment. Just a point on a line, which we can do by construction and point along a path I used, and just grab that and you just select the path and tell it where along the path you want that point. Alright, so that creates a single point on there, which we can see under construction. It becomes that point, and then I can use that to create a plane. Now, to do that, I've simply gone construction plane through 3 points, and I selected the point down there and a point at that vertex and the third one, which gives me that plane you can see there, which is at an odd angle to the vertical and is basically in alignment with that section. What I can then use that for is to create a new sketch. Now I've got a sketch in there, you can see I've created it using that plane as the base, and that gives me the ability to create some rings on there. Now there's a lot of fiddling around trying to figure out exactly the right size, but what we're looking at here is basically one ring. Let's edit that for the sizes, edit that there. I've defined how far up I want that to be from this node, which is projected. The size of the hole that I want. Now I want to be reasonably big to be able to get the stuff in there without too much trouble, but not too big so that obviously the cap that goes on it needs to be bigger, and I don't want it to be too much bigger. So I've decided I want 15 mil. I want a 3 mil wall thickness for it, so that gives me a cylinder I can project, and this outside one here, 8 millimeters, I can use for the cap. So I finish that. What I do next is I project the cylinder, which is going to be the nozzle, and I've just projected it in 2 different directions. So we can edit that, we can have a look. So we're going from the profile plane, we went in 2 different directions. One is this one, which is a distance of 10 millimeters off the surface there. The other is to object. Now the reason I've chosen that is because it will project to that surface at all the variable different distances it needs to be able to connect. So we've done that, and that gives us a nice finish edge there. The next thing we did is I want to punch a hole through. Let's turn that construction plane and the point off, and if we do a section again, let's do an analysis, vertical along midpoint. So now I have taken the same thing, I've used the same sketch and taken a cut from the center there through to the middle. Now I've just selected a nominal to object, so to the inside surface, to make sure it doesn't project through, and if I change the thickness it'll happen automatically update. And that gives us the hole through. And so that was nice and easy. And let's just wait while it recomputes. And then I've tried to do some additional things, and we're creating a couple of extra sketches here to build things out. But let's progress further. So the next thing I want to do is create the thread. Again, really easy. Thread command in here. Now we've got the cylinder, so it's simply a process of minimize that. Let's go thread, and then we pick that surface. And it will recognize the diameter of that cylinder and automatically pick a size and a recommended thread. It also relates back to what you've done before. So let's go back to there and let's edit that feature and see what I did. So what I've done is I don't want that to, if I make that as a full length, you'll see there it starts cutting into the body. We don't want that. So I'm going to say not full length. And that allows me to define a length for the thread itself that doesn't go the full length of the cylinder. So let's take that analysis off, and you can see there I have selected a random point which is 9mm, giving me a good bit of meat here for the join. Now that'll come important a bit later on, but 9mm should be heaps of thread. 22mm, and I've picked the largest thread I could because 3D printing, that makes it a bit easier. And I happen to find that it works well with the isometric. And you can ISO imperial as well, or the ISO pipe threads. It works for me, it works on the printers I typically use. And so that creates the thread, really nice and easy. Cancel that so that stays. And from there, it was really, I decided I wanted to create a new body for the screw cap, so we'll cover building the screw cap next. Okay, so the screw cap's going to be printed separately, or at least as a separate component in the 3D print. So I decided I wanted to make that a new body. So what I did is I come up here and I create a new component, rather not body, new component. And that is a component there. We've got screw cap. I'm going to turn that on, and I'm going to turn off the other parts of this. Expand that, and I'm going to make that my active component. There we go. And you can see all the commands through here, and we end up with when it's finished processing, you can see there a screw cap that fits on the rest of fits in the thread. So how do we do that? Let's go back a couple of steps, and let's isolate the screw cap. Let's not worry about that. So we can see the body there, that's fine. What we want to do is we extruded first, we picked the thickness we wanted, so the main part of the body, but we're going to add the thread to. You don't have to pick this in a ring because the thread will adjust that body to suit, but I chose to at the time. Extruded that 5mm, and I chose to pick the start plane from the end of the thread body, and then project it 5mm down from there, which is going to give me a 5mm thread depth. And again, you can make that any thickness, but I'm just conscious that the threads are going to get close into here, or sorry, the cap is going to get close to the main body, and I wanted to make sure that I allowed space for people to put a extra bit of foam or rubber or something around here if they wanted to, without occluding the nozzle of the cap. So you can make it deeper if you need to. The next thing I did, let's cancel that and go next, was to project the same body. So we selected the profile planes, which are the 3 rings from the outside and the inside and the hole, and I projected from the surface of the first part I created, and I projected it further up by 2mm, being the thickness I wanted, and joined it, which gives me the body that I need. Let's trot that back. Alright, so that gives me, let's turn the rest of this off. there. Nope, that's what I want. That's the screw cap. Why am I getting the other bodies? Let's turn analysis off. And that mask body off. And why am I getting... That's the body I want. Mask body. Turn the mask body off. There we go. So that gives me a cylinder like that. Next thing I want to do is simply put a thread into that. And that's a simple process like we did before. We just simply select the face in the middle and assign a thread. So it comes in again, but you need to specify. You can change this size here. So if I decide that needed to be 15, which I don't in this case, it will extend the body to match it. So it's always going to be fairly easy to modify. But we want to stay at 22 because we want 22 by 3 to match the thread we've added to the mask body. That's all good. It's still the same as the other one. Now I'm happy for that to be fully modelled because I want that to go all the way through. Turn the analysis back on. We can see that goes right through to there, which means you can get a good seal on the inside. And I wanted to make sure you have these modelled if you're 3D printing. If you don't have it modelled, all it is representative. Fusion knows it's a thread, but it's only a picture. Okay, so you want it modelled to actually show that. If you've got a lot of threads and you're not actually 3D printing, you can turn them off. And the other trick there is as well, you can change that in the document settings up here for all of the threads. So we can turn that to cosmetic, and it will adjust all the threads in the model if you're having performance issues. And then if you need to, you can come back in and change it to not cosmetic for individual threads that need to be 3D printed. Okay, so this is the default for the model, and again, if I need to make that back to cosmetic, I can do that for all of them. But in this particular case, because both of them are being modelled, I want them to be both modelled because I want to see those, and that's what needs to be 3D printed. So that's good. The next thing I did was part of a sketch. I like to put my Freedom brand on there, so I did a sketch, a bit of text, and then I can extrude that onto the surface. The other thing I've got here is I like to put some bit of grippy stuff. So I've got two circles, and I just picked a distance here. The angle there, the two circles are the same size, and the angle is something divisible by 360 to give me a regular spacing. Now I'll show you why I do that, because the next thing I want to do is a chamfer. Now that just makes life a little bit easier to come in the next step. So I'm going to chamfer that edge. Let's get rid of that sketch for the moment. Which gives me a nice sort of feel for it. I'm going to print this from either this side or this side. It doesn't matter too much, other than we're going to have a bridge here. So I would print this with this surface onto the print bed in sort of that orientation, sort of. If that was square, or somewhere around there. But what we want to do is have a look at creating some knurling. So what we do is you get that sketch, and what I've extruded, let's get rid of analysis, one of those circles down a certain distance. Now I've left a deliberate space there because I think that looks better, and it helps a bit of structural integrity and gives us a low surface here. You can run that right through, does not matter. So once you've got that one, the next thing I do is I fillet these edges, which gives me a nice curve and a nice soft feel without being sharp, and then I pattern that around. There's a couple of ways you can do that. In this case I've picked features, so I've actually picked the fillet and the extrude feature from a timeline, which has two selections rather than the three in here, and I've used the pattern circular feature. So I selected the features to do that. The axis I have selected is any one of these circular features. So it could be a line here, could be this ring here, anything that gives you the center, and that then runs that around all around the outside. I've told it 36 because I knew that I had the 1 degree in there, and I left it at adjust and OK, and that projects all those around there, giving me a nice lumpy edge with a bit of grip on it for your fingers. I also extruded the text in the top. Now that's the print bed, that should print nicely. Okay, so we've got the screw cap and the body here now finished. If I turn now so we can see them in full. And it should be nice and clear. There's plenty of thread there for the thread cap to engage. Like I said, you can make that deeper if it suits. Depends. This is not designed for a gasket. I would make it a bit deeper if I was adding a gasket. But I want to check something now, depending on the accuracy of your 3D printer. I'm going to put the analysis back on there. Threads by default have a clearance. Now if I do inspect, let's zoom right in, inspect between that surface and that surface, we'll see there it's 0.07 millimeters. Now that's fine if you're machining it out of steel or something like that. A lot of printers don't have, 3D printers aren't that accurate, and typically you'll get binding between the parts. Now we're not going to print them together, so that's not a problem for binding. However, if you want to make sure, if you've got some tolerance issues, your printer might extrude a little bit of over extrusion, things like that, to make sure you can easily thread that on. It's not too bad. Now you've got to remember the sealing surface is actually this surface here. And if I turn the screw off, screw cap, this surface here is going to embed on there on the screw cap, and that's where the most of the seal is. You will get some engagement on the threads, but that's where you're going to really get the seal value. So what we want to do is make sure that goes right through, and having a bit of looseness in the screw thread is not going to be a problem. So what I've done here, you can see the two steps. I simply, actually let's turn that mask body back off again. I want to loosen that up, and what I do is I simply select one of these faces, and it takes a moment for it to progress, but I'm going to pause it while it. So edit that feature. You can see I've selected one side of the screw face. Now that's a helical face, so it's going to select the entire thing, and I've offset it by 0.01 because I want to just add a little bit more gap for a printer error. And the second one does exactly the same thing in the other direction. And if I turn the body on, you can see there now we've got a good healthy gap. I'm not too concerned about the gap between here and here. That's already pretty healthy. That just gives me a bit of error margin and prevents the thread from binding up too early. Again, that would maybe depend on your particular environment. If you've got a printer that's a bit more sloppy, you can make that a bit bigger. But again, the important thing is the sealing surface should be here on this flat face here. Okay. Now you'll notice as part of this, I didn't cover it earlier, I have added in two extra components, and they're mesh bodies. If I turn those on, you can see these are the components that hold the filter material. One of them is pushed into the mask. Let's go turn it around that way. So this is the way the mask is worn, is pushed in from that side. If I just do a move on that, it'll demonstrate that. So it sits out and you push it in from there, and you can see here on the profile of it, there's this ridge line there. That is designed to push past this plastic piece here and snap in on the other side. And the grooves sit in there. You can see there's a flush surface, there's clearance for that, and it snaps in on that angle there. So that's fairly nice. And then the second one, I'm just going to cancel that, is this part. Now it is fairly straight, although if I turn off the mask body, you'll see around this side there is a little ball there that sticks out, and that's the only thing that interferes with the other half of the component. Let's turn that screw cap off as well. So when they snap together, those balls attach to these little recesses designed into this this half. So it snaps together, holding the filter material in place. I wanted to make sure they fitted properly, so I've simply inserted them as new components. That allows me to do joints. Not that I have worried about it in this case. I just wanted to position them, and I've just done that manually to check that they fit. Now that's just simply inserting the mesh and then using that move command to position them. Having it sectioned like this makes it nice. I can make sure I get that square surface there, and I just move it back and forth until it fits. You can see there, I've probably gone a touch too far. Let's move that one. Is it that one? Let's move it back just a little, and I need to go back out just a touch to find the arrows. I like to click on the arrow and then just move it whatever. That highlights this, and then I can simply just go negative 0.1, and then I can move in. That graphic's always going to be there. That's way too far. Let's go 0.5, 0.05 rather. Oop, too many zeros. full stops, maybe still too far, and I can see that up here, and maybe I put in, make that 0.1, something like that, and you can play around with that, really easy, capture position, and that's done. You can see there the gap's really, really nice, and so that proves that they're fitting nicely. I checked it in both directions. That one's not going to work by the looks of it. Which direction's that? I'm not sure what that is. Edit that. Let's pick a different coordinate. Let's find the origin and select faces. Origin face. Oh, okay, so we're selecting that there. So that's actually a really interesting one because that's showing us the hollow section and the way the nozzle comes in. That comes back in useful later when we're going through that. Okay, so I've got the two components. Let's turn that analysis off. Sitting in situ inside the nozzle, inside the mask, and we can see that everything is fitting together nicely. Moving forward in the timeline, and what did we do next? The next thing we looked at is, you can see, so we've proven the mask, it fits nicely, we've got the screw cap there, everything's working. We just want to make sure now that we've got to be able to attach it to our face. There's no strapping now. We took that out right at the beginning, and we need to add them back in again. There's a number of different ways you could do this. The way I chose to do it was as follows. We've got a sketch. Now I've drawn a sketch just in random space to create an object. So let's turn everything else off. I've created a new body. You can see there. So I've created, let's just hover over that new strap slot, and I renamed that because it's a new component. It allows me to do some moving and carrying on. So let's highlight that and turn everything else off. Now, nothing to see right now. We've just got a sketch. So if I expand that, we can see the sketch. And all I'm doing is emulating the shape of the strap in the original mesh. Now, if I look at the mesh there, what I'm talking about when I say strap is turn the bodies on, and let's just make that dark so you can see it. That's the wrong one. Is these components here. So they were removed in one of the meshes that I used. There, we took them out. If I get rid of that mesh, pick the right mesh, must be the last one. So we need to put them back in again. So I've taken some measurements on them, the overall, that shape there, the size of the hole, the depth, and just sort of where they are roughly to get an idea of what was considered appropriate. Now I've got to want to 3D print these, so I put a fairly, obviously we need to have this angle here. Let's go back down to there, to be greater than 45 degrees. Now I've picked a fairly high angle, and to be honest, I did check that when I'd mounted it properly where I wanted it on the mask, and come back in here and edit the sketch. Great way to deal with that. So the edit sketch, I've made it 30 degrees, 6mm by 6mm, and what that allows me to do then is just extrude that again to a measurement that I defined. Really simple. I've just selected the profile. I've done an overall distance of 12mm, half an inch roughly, and I've said I want it symmetric, so we're getting it around that sketch. And then I need to do the hole in it, so we've created a sketch on the top. Now there, really nice and easy, I have just simply done a slot, which you can do through here, slot dimension. I think that one's a center to center, and added that in. So all I need to do is dimension the diameter here, so the width of the slot or the depth of the slot, and that determines the arcs and everything that direction. I've snapped it to the middle, which is one way to keep it central. So I've drawn these two construction lines to snap to, and the 2mm from the end then automatically dimensions this from the same end because it's symmetrical. Okay, so having done that, we finish that, we extrude that through, and we end up with a hole. Let's turn those sketches off, going right through for the elastic that is going to attach to your head. Now I want to just tidy that up, make it a bit more clean, so I've simply done a fillet there. Nice functions with fillets is we can just pick a bunch of edges, and I've picked all of them. I have picked edges because I didn't want I could have done faces here and maybe just picked 1, 2, 3 faces, but if I do that, it's going to fill this bottom edge, and I don't want to do that because I want to make sure it's fairly clean through to the mask. And then the last thing is I've joined that to the to a component. Now let's just come back up and have a look what's actually going on. So go back to here and the mask body on, I think. So you'll see there's a whole bunch of them appeared automatically. What we need to do is we need to go back and activate this body here, and you'll see there's 4 of them. So we'll go back to the timeline a little bit and see what happened there. So in the timeline, I'm going to grab that, I'm going to drag it back to where I did the fillet, and that's that fillet on, I've lost it, there it is, that's where I drew it. So I moved that component and it's been drawn there. So what I've then done is I've copied, so what I've done is a strap slot there, I've moved it and put it in that place and then captured that position, and I have then gone, what is it, copy there, and then on the 3D mask I've hit paste new, or paste. That is simply to duplicate that component. Now let's just test whether I did paste or paste new. If I offset that, you'll see that does both components. You can see it over there. That means that I've done paste, which means they are linked together, cancelling that, which is great because it means I can go back. If I go back and edit this original component, it will do that. So we've done paste new, and then a component appears, and we do that again. And I've done the same to get 4 straps, 2 strap slots there. Move them into position, and that's just using that move tool to get it exactly where I want it again. You can rotate in all 3 axes, depending what you want to do. You can use these to to move it around in a plane, any 3 planes, or in a particular axis direction. Cancel that, and it'll go back to position. Capturing position in that tool will save you having to have an extra capture position marker in the timeline. That's why you don't see it there. So that's been put there, and again, because this is a mirrored design, that's all we need to do at this point. Now they are not connected, they are individual bodies. We can turn them off and they're just sitting there in space. I have ensured that there is an interference between the bodies, and what I was looking for is making sure that while it interferes with the body, I'm also wanting to make sure that it doesn't go too far through, so we don't end up with this weird anomaly on the inside. So we can see there, it is getting pretty close, and I probably could have done that a little bit better to avoid any artifacts in the 3D print, but it doesn't actually interfere, so that's good. And we go further back, there we go, further back. You can see there, it's all going to be within the body. So when I join that, it's going to be nice and clean. Let's cancel that. Turn the analysis back off. So next step is to get the other side. So a simple mirror command there, and again, easily enough with components, because they're components there. Another reason I chose those. Mirror plane is the axis, and we get 4 of them. Now I did a bit of tidying up there that I wanted to do in the process because of I felt they weren't quite sitting well enough, and then I combined them. So let's have a look at how that worked. I went through and I selected the target body, which is the main mask body, and then the 4 tool bodies, 1, 2, on this side 3 and 4. Hit the join. I'm not keeping components, I don't want them anymore, and I hit OK, and that creates that into, if I go to the mask body, we'll see that's now one single body. I can turn that off and they all go away. There's no strap slots. If we have a look at them, there's no bodies in there anymore because they've been removed, because they've been joined. So the next step for me was, now that I'm done with those, I'm going to remove those bodies or components just by right click and remove, and that just cleans up our project tree. So now we've got a bit of an odd situation. We've got the 3D mask here and a mask body component that is the only body in this assembly. So I decided to rectify that by moving it. I was able to, you see this move command here, or cut and paste body, simply drag that up into that spot there and correct that. So now that the body is under the assembly section, you see body 3, and the mask body has nothing. So I've then simply removed that again by right clicking and selecting the remove function. So we've got the main body and I'm pretty happy with that, but I want to do some cleanup to make sure that it seals well and there's no particularly sharp edges for 3D printing. So we had a look at some filleting here, and it's sort of slow me down there. 1 second, I'll come back with. So what I've actually looked at there now is where these sections come in. So horizontal inside face section, turn that analysis on, lets me look at the inside. You can see where I filleted here. Now that was done with a face fillet, so I want the entire, to make sure that this corner sits really well. Let me just unselect that. So we've selected the face, and that's going to fillet any corners that meet with that face. So it's realistically these 4 edges, where these edges around here, and I've said 2mm was the maximum it'll allow me to do, and that creates a nice curve in there. Because we're printing in this direction, that means we've got a bit more meat, and we're going to be able to have less chance of any leakage. And you can see there that you get that nice curvature in that surface. Now the next thing I did, I wanted to chamfer the inside of the nozzle, only to give it it doesn't really need to be sharp or chamfered necessarily. This makes things, when you're trying to get anything out of it, a little bit easier, and just makes it a bit more tidy, I think. It takes up a little bit less material. So I just chamfered that inside of the nozzle while I had it sectioned, and I did another chamfer there on the outside. So if I take that analysis off, you can see that I've chamfered this point there. If I edit that, you'll see it's an interesting artifact because it's a mirrored function, and it's at an odd angle. It's not a circle, it's actually 2 splines. So you need to select 2 elements there to get both sides, one there and one there. Okay, so let's cancel that. So that gives you a good structural point, reduces any stresses that might occur on that join, and reduce the chance of it snapping off if it's dropped or bent. Because if this is frozen, for argument's sake, or heavily chilled, it's going to be a little bit more brittle when it's cold. Now the last thing I tried to do on the inside here, I wanted to replicate another fillet. Now if I tried to fillet that, it just didn't want to work for me, and I wasn't happy with the way it worked. And it was all to do with the interfaces here, ultimately probably to do with the meshes and just the finite detail not being quite right. Ultimately you're not going to be able to see anything, so what I did, I drew a sketch, and if we edit that sketch, I've just bisected it there on the plane, and there's some weird things going on there with that sketch line. But what I was really interested in doing was producing a radius in here. Now I'm not sure what's actually happening there. So that's an artifact of what is going on with why it's not going to fillet for me. So coming back over here, I've just drawn these lines. These are not straight lines, they're all spline because it's a face. So it's very difficult. I couldn't even tangent that for some reason. I have put in, I just thought it was a 4mm worked well, put in that radius, made sure that that interfered, and if I turn that body off, you'll see there I was able to get a region by making sure that this, while it's very close, it's not actually tangent, it actually goes across the line, but it'll do, and the rest of the software will manage it. The other half of this is really fairly easy, so I turn that off, and the next step is I'm going to use it as a sweep. So that sweep's kind of interesting in that when we produce that, we select the profile and a path to sweep it along. Now the path I have selected, if I select that, you can see, turn the body back on, is the path around the inside. Now it's I was able to get one path, which is awesome, and that then will sweep it around it. Now I'm doing it as a new body, again because joining it was going to cause problems, and you can see down here there's looks like there might be some weird functionality there right at the join, so that's going to create some odd things. So cancelling that, we'll finish the sweep, and then I just did some lofting and some tidy up. So I noticed here at the join, again, artifacts of why it's not working. I did a loft between those two surfaces to close that up, so now there's no gap. It cleans up that fillet really well. What I didn't realise until just now talking about it, if I turn the body back on, there's actually a really odd gap in there. So if we look in there, we can see there's a surface in between those two bodies, between that main mask body off again. Something really weird going on there, which we might want to address before I go back and reprint it. So improvement feature for me there. This did however print just fine in the tests, so it was functional. I didn't actually worry about doing anything about combining that. I didn't think it was necessary. Again, you can see there's a bit of an issue. Maybe I can just do some sort of offset there or something. Try a Q. I think it's going to have issues, so I'm not going to worry about it. It's certainly grinding. Yep, went too far and it had a bit of a problem, so I'm going to cancel that. However, the next thing will be to 3D print that. I'll show you very quickly in the next thing how I'll push it through to my slicer. Yeah, we can show you how that works. Interesting about that, not really an issue in the printing. Okay, chat in a few minutes. Okay, so the last thing now, we've got all this built out and ready to go, is to print it. What we want to do is, now we've got the 3D mask here as two bodies. Really simple. If we come along and we just export this to STL, we get the option to be a single file or one file per body. In this particular case, I want it as one file, and I can actually tell it to go to my slicer directly, which is a nice cheat because that means that both those elements are going to go into that environment. Alternatively, the other way to deal with it is just export it to a file, save it as an STL into a directory, and that way if you want to update it, you can simply replace that file and then replace that in your slicer. Now I've used Prusa Slicer, which is launching now, and that brings that in, and you can see there, looking in here, that fillet has been rectified by the mesh. I've got to remember how to orbit in the Prusa Slicer. You can see there's an artifact in there. We'll see how that slices in a moment, but it's very hard to pick up any other way. So that's it there, and doing it that way, you don't have the cap coming in. If you wanted that as well, there would be ways to deal with that. We could have simply come in and done it as a separate one. I prefer to print it separately just because it's a very quick print and you're less likely to muck it. If something goes wrong with the mask, you haven't lost that as well. So back to slicer. Come in here, we can do the setup in here. Let's run it as, I like it as a 0.15, just because it gives me a bit more quality on the slice, and I get overlap and a bit of accuracy. Prusa Slice is wonderful. You will need to run supports for the thread, or at least you should, because there's a bit of there hovering in space. The rest should be okay. You notice that the interesting thing here, there is very few overhangs. You can see the hollow space in the middle, and as we get down to the start, you notice because we're using the thinner print layer, then we're not getting these overhang layers because we're able to do the bridging for most of these. Now these are going to probably artifact a little bit weird. You can see here on the nozzle because there's no support, but putting supports on the nozzle would be a good way to deal with that. Coming down, you can see here, look at the front of that little artifact area. Let's see how it's going. You can see it has picked that up. If we go down layer by layer, you can see there, right at that point, you're going to get some really odd cavity. I don't think that's going to be any issue. It's certainly not going to have 3-4 layers still in here of thickness for integrity. I don't think you're going to have any issues there. There's plenty of meat. It's just an odd little thing that's going to happen. And the print, a few layers there, and we get to the bottom. Now, I would suggest putting on supports from the build plate only. That will rerun that slice. And that's going to actually, in my case, it will often run up to the side supports. Of course, you can adjust things. See, there we go. To adjust the angles of what you're supporting. I've occasionally find that's not always accurate. I don't think this needs it. It's really only there, if you look when you go through it, to support that bridge in there, just as that hole closes over. I think that's going to bridge fine. It's certainly not registering as an overhang perimeter, so I'm not really sure why it feels the need to print that to support that. What I would suggest is simply adding in the slicer space, come in here, add a modifier, a support, so add a modifier or a support blocker, whichever way you want to go. Let's try blocker this time, and generic box, where'd that go? Of course we need to go to the model space, don't we? So that's that box there. Let's move that over to there, change the size, oh, wrong way, scale, change that direction and that direction, move it over a bit, that's fine, scale it back, let's go bigger and a bit wider. So we're covering all of that there, but allowing the nozzle to have supports. Well, let's go a bit wider just to make sure. It doesn't matter with this if we go too big. We just want to make sure that we allow that nozzle to be supported. So, okay, so that's nice. We can do that there. We call that a generic box. That was a blocker. Change type, just see it, so it's a support blocker, so that's fine. So build plate only, slice again, and it'll run through that. And this time you'll see we don't have any supports around these bridging locations. So that's good. It's good to support the nozzle here. You could change the orientation, but I fear the supports would be bad. The test ran these supports really well. You could try it without, but I wouldn't recommend it. You need to do a lot of cleanup. The original test didn't require much cleanup, and again, that's that offset we put in of 0.1 mil on each radius to give you that clearance and a little bit of flexibility. If you really wanted to, you could possibly orientate this potentially, so you select that orientation onto that face, but there'd be a lot of let's take that support blocker out to joint box. Can I delete that? But you need to support the underside completely, and I expect there would be need some support on the inside as well. So, real lot of waste and not the best way to deal with it, just to get a slightly better thread. You see a lot of supporting required there. Not what I would recommend. Anyway, once you're done there, the only other thing to do is then go back into Fusion 360 and pick on your screw cap and do the same thing, run it to your slicer and add that in. Now this one, again, we want the top of the screw cap to the bed. That's going to launch a new slicer in just a moment. There we go. Choose again your style. I would just simply pick on that and tell that to go down to the bed. Again, pick your quality, slice that, and that's all you need. No supports required. It will generate that nicely, and you see that's 26 minutes and you've got your cap. It'll be a bit longer if you've made it deeper. Alright, so print that and see how you go. The whole idea of this is once you're done, what you do is you attach some elastic through here to go around your head as desired, however you want to attach that to these points. Unscrew the cap, fill that with some freezer pack gel or some other liquid. Alcohol, rubbing alcohol was used in one example, and seal it back up again, freeze it, and then you can wear that keeping your face cool. Otherwise, put whatever fluid you feel is appropriate, and you've got something to drink on your face if you need it. It would get a bit heavy though. Water would be interesting because it'll expand once it's frozen, so freezing it might not be the best idea, because if you filled it up that would expand and you'd probably fatigue and potentially break the print. One option might be to print that in flexible. I'd be really interested to see that if anybody does it. But apart from that, I hope this has been helpful. Hope you've learnt something, and if you'd like to see other things or would be interested in looking at any of our other models, if you have a look at our Freedom website, you If you ever go to the 3D website, they've got plenty of shop stuff over here that we've been building previously, as well as information from our Thingiverse page. Anything that is shareable is on Thingiverse. These prices here are just estimates if you want them printed for you, and plus shipping, of course. And just to give examples of things we've been doing. Look, reach out if you've got any questions. We've got the contact us page here. You can email us directly.